Look quickly here at how the mean can be calculated from grouped data. So here I've got some data which shows the distances that a javelin has been thrown by a class of boys, and we're going to have a look at calculating the mean distance that this javelin was thrown. Now the problem is that when you've got data that's been grouped, you lose what the individual pieces of data were. So for example, on this first one here, I know that a javelin was thrown between 5 and 10 meters, but I don't know exactly what that data value is. And for 8 pieces of data here, I don't know any of them individually. I know they were between 10 and 15. So when it talks about estimating the mean from group data, there is a very specific way we're expected to do it, which is to use the midpoint. If we know that the javelin was thrown between 5 and 10 meters, we don't know if it was 5, we don't know if it was 10. The best estimate that we can give is to go exactly halfway in between and say it was 7.5. So that's the approach that we would take. So if we're trying to work all these out, we basically work out the midpoints for each of those class intervals. And if you're finding it difficult to calculate the value, then just add the lower and the upper limit together and divide by 2. If you think about how we calculate the mean, what we would then do is basically add each piece of data together. And what we can see here is that, for example, with the 12.5s, there's 8 of these. So normally that would mean doing 12.5 add 12.5 add 12.5 and doing that 8 times. And obviously a far quicker and more efficient way of doing that is to do 12.5 multiplied by 8. So ultimately, to work out what the data added together would be in this category, I do 1 multiplied by 7.5. To work out the sum of the data in this category, it's 8 multiplied by 12.5, and so on and so forth. So I multiply each of those columns together. And finally, to work out what the sum of all the data would be, I add this column. That's the sum of the data. And then I also will need to divide by the total number of pieces of data, which is the total of the frequencies. That is how much data or how many boys were surveyed in the first place. And if I do that calculation, I'll then get the estimated mean, which in this case is 19.3 meters to one decimal place. And you should always, whenever you calculate a mean, then just have a look at the original data and see, does that value seem to make sense in the context? And if we look over here, we can see that the modal interval is between 15 and 20. We've got a little bit more data pulling the mean down towards the bottom rather than keeping it up at the top. So for us to have a value of 19.3, something that's slightly greater than this midpoint, seems reasonable when you look at the shape of the distribution. So get into the habit of always doing that when you've calculated things, because it's very easy, particularly if you're doing it on the GDC, to type one number in incorrectly. But you should very often be able to pick up on that if you're always doing a quick check, looking at the way that the data has been distributed.